So the last material on this front page of the data sheet was just taking a few more things and reacting them up with hydroxide. So all of those hydroxides with these metal ions. Now, of course, we've actually covered some of those already. We said that the lead 2+ with hydroxide gives you a white precipitate, which then dissolves upon adding extra hydroxide to it. And here again are the pictures of what happened there. Lead 2+ plus hydroxide initially makes the precipitate, the insoluble lead hydroxide. Keep adding hydroxide to it, and then that lead hydroxide solid picks up another 2 hydroxides to make this tetrahydroxy lead anion there. And the reason it does that is because lead is amphoteric. Now, we talked about with the hydroxides, magnesium, calcium, and barium. White precipitate, no change because the solubility of the hydroxides increases as you go down the group 2 group on the periodic table. And these are not amphoteric, so no change with extra hydroxide. And in the last movie, we just very handily added hydroxide to copper 2+. We got that pretty pale blue precipitate that again did not change with extra hydroxides because copper is not amphoteric. Also, I could have talked about with the silver ions, when we added hydroxide to that, we got a dark precipitate that was essentially silver oxide, and you would have seen that silver oxide if you did the organic one when you did the Tollens test, but we're not going to worry overly about that, and nothing happens to that when you add in the extra hydroxide. Purpose of doing this part though with these last 3 ions, Al3+, zinc 2+, and chromium 3+. Initially, when we add in hydroxide for the aluminium 3+, we get a white precipitate. This is just the aluminium 3+ ions with 3 hydroxides to make the insoluble aluminium hydroxide. If we add more hydroxides, however, that dissolves because similarly to the lead, we add in an extra hydroxide to make this tetrahydroxide anion, tetrahedral anion there that is soluble because aluminium is amphoteric. I'm not going to show you a picture because again, white precipitate dissolve and who cares. Zinc is another one. We take zinc and we add hydroxides to it. Initially, we see a white precipitate of zinc hydroxide. Add in more hydroxide, it dissolves because we again make the tetrahedral tetra zinc hydroxide dianion. And finally, chromium 3+. We're going to do a lot on coordination chemistry and future movies. Chromium 3+, when you add in hydroxide, you get a green precipitate. You can kind of see the cloudiness of the greenish blue in there. The precipitate is the green one. And that is the formation of chromium hydroxide, insoluble chromium hydroxide. However, keep adding hydroxide to it, it dissolves, and you get this lovely sort of greeny blue solution that is the octahedral hexahydroxide chromium trianion. Okay, all 4 of these ions are amphoteric, which is why they behave like this. One characteristic of amphoteric ions is that when you add hydroxide, they will initially precipitate out the insoluble hydroxide, but then they will react with further hydroxides to give you these anions, which are soluble. Okay, lead, zinc, aluminium, and chromium 3+, all amphoteric.